Like that, we should try to design network security protocol through the set of rules internally, in order to enable all these things by using the functional box which we discussed till now. Like we use the various cryptographic algorithms. Okay. Now the question is, okay, we will discuss on this particular thing. Where do you want to provide these rules? Whether you want to enable at application layer, transport layer, network layer, or at the lowermost link layer. Where do you want to provide this particular thing in the protocol stack? So just you can very common sense we can understand. Whenever you try to enable at the application level at both ends, that means as part of the application. Like for example, if you take the example of SSH, secure shell, okay, it is enabled between the client, SSH client and SSH server. Now what happened? This application is defined in such a manner that all the communication between the client and SSH client and SSH server is encrypted or secured. Now, when the data passes through the protocol stack at one end, sender end or receiver end, the payload will be treated, whatever payload received from the application, okay, whatever data it is received, whether it is a normal or encrypted, it will be just treated like a payload by the lower layers. And because the headers and all are open, because all the other layers of the protocol stack, they are not doing anything, and the headers are added by each layer, so that these headers will help you to communicate or route the packets to the proper destination. They are not doing anything, whether it is encrypted payload or normal payload, it will be just treated like a payload and sent to the right machine. By using the headers, it will be routed and given to the destination. Once the payload is received, the receiving end SSH server will know what has to be done and it will try to do it. Whereas if I try to deploy the security at the lower layers, I may be encrypting more details like headers and other things, but my intermediate devices need to be aware of the details which are encrypted as headers, so that they'll be able to route. So as you go down in the protocol stack, deployment of security protocol, you may be able to encrypt more details, including the headers and all. But the problem is, by encrypting the headers, the advantage is it will enable, definitely give more security, because traffic analysis and all cannot be done. But the problem is, all the intermediate devices, the router level or other the link level, this thing, the devices should be aware of what the security protocol is that, and so that they can decrypt, look at the headers, and then once again encrypt packet. So as you go down, you'll be able to enable more security, but the problem is the intermediate device need to be aware of. Whereas if you do at the application level, definitely only application need to be aware of. All other layers will treat it like just like any other payload and then do that. Okay. Now over the period, if you look at it, the various security protocols have evolved. Okay. From 90s, secure electronic transactions and pretty good privacy. See, SET or secure electronic transactions is a protocol which is meant for banking across the vendor, customer, and the bank. Whenever something is purchased by the customer through a particular vendor and bank, to secure all these operations, SET protocol is designed. Okay. PGP or pretty good privacy is again a protocol which is meant for file transfer operations. So all these protocols are internally making use of the cryptographic algorithms which we discussed till now. So later over the period, like SHTTP or something is meant. Presently, if you look at it, after that, around in the 2000 or so, or initial or 1998 or something, at that point of time, Netscape has come out with something called SSL, Secure Socket Layer. What is the objective is, rather than trying to build a protocol specific to the application requirement, why don't we try to generalize the security requirements for all TCP based applications and evolve a protocol, so that irrespective of whether it is HTTP or FTP, SMTP, if it is a TCP based application, it can try to enable the security in this manner. That is how the standardization has come at the transport layer security, which is received just above the TCP. And later, in 2004 or something, 2 and other things, people have come out with IPsec kind of solution, where IPsec, the security is enabled at the security protocol is enabled at the IP level. That is what we call as a IPsec VPN, SSL VPN, IPsec VPN, like that. We try to use the different terminology. Okay, all these are nothing but the security protocols which are going to provide secure communication between the two different ends. It can be at the application level, or it can be at the transport layer, or it can be at the network layer. When you do talk about network layer, it does not worry whether it is a TCP packet or UDP packet, nothing. For IP layer, it is basically incoming packet and outgoing packet. That's it. Okay, it can be TCP or UDP. It can try to apply the security like this. So just let me take, I think, another 15 minutes or so. I think by 4:45, I will try to wind up the session. So just if you have any doubt, is it okay? You understood the importance of network security protocol? Hope you understood what's the importance of this particular thing. See, network security protocol is nothing but we are trying to enable, design a protocol, network security protocol, through by exchanging the set of rules across the two ends, you are enabling the various network security services. How you are enabling, for that we depend all the algorithms and other things, whatever we discussed till now. Okay, so pretty good privacy is something which is the application level security, which is used basically for file transfer encryption, as well as also for the email encryption. So which was primitive kind of thing. Okay, so which is developed by Philip Zimmermann, meant for email security, can be used for securing files. See, what happens is even email is treated like a file. It is basically you can integrate with your email system, but the problem is email is also treated like a file. So whenever it receives or whenever it sends an email or wherever it is, it treats like a file and carries out the encryption and decryption. Okay, so PGP integrated with mail systems are also available. Okay, so how it is going to, what all the things it is going to do is that it is going to provide authentication. It is going to provide, see, these are ready-made solutions. I should not worry about how I should use public key algorithm, private key algorithm like that. As a responsible person to secure my networks, I need to know the suitable solution. I need to deploy. I need to know the services given by that and use it in our networks to secure the infrastructure. Okay. Now PGP provides this kind of security, authentication, confidentiality, compression. Okay, Radix 64 conversion. I will explain you what is Radix 64 conversion for email compatibility segmentation. We will understand that with a pictorial representation. Okay, so very simple. Whatever we understood till now, from that you can understand within no time. So how it is going to do authentication? Just you can see that message first it will pass through the hash function. Okay, it will give the message digest. Okay, now message digest will be passed through public key cryptographic algorithm with sender's private key. Now this will give the digital signature. Okay, signature which will be sent along with the message to the other end. Okay, so with this this particular, by using this one, you are able to enable the authentication. Now what we'll do for the confidentiality purpose and all. Okay, now another step, see, to reduce the size and other things, it will also use the compression stage. Once it is compressed, then it will pass through the encryption. So what is the encryption we are talking about? Will depend on the symmetric key algorithm. Once compressed, okay, this will pass through the symmetric. As you are aware, IDEA International Data Encryption Algorithm is basically a symmetric or secret key algorithm, which will use a key, okay, session key, okay, and then one-time session key, and then it will encrypt that particular thing. You will get a, okay. Once you have this, the session key, how you will try to give it to the other end? With the receiver's public key, you will encrypt the session key. So that you will end up with a, what is that? Encrypted key. Okay. Now this will be encrypted message and key will be sent as a file with the image. See, now what happens is it will go through the encoding phase. Okay. Conversion stage, Radix 64. The idea is once you encrypt a message, you end up with scrambled data, which may not fall in the email compatible characters. Okay, email compatible ASCII or Unicode, no, it may not fall in that category. It may end up in some kind of binary data. So when it will end up into some binary data, the email systems may not accept, especially primitive email systems like before your MIME headers and all, the email systems may not accept. So for that reason, to make the data compatible to the email systems, it will pass through the Radix 64 conversion for email compatibility. Okay, so that is how the Radix 64 conversion will take place. Okay, and also to take care of the sizes, restriction on maximum size of the message and all, it will have a mechanism to divide into segments, and the receiving end again it will try to reassemble the things. Okay, so these are this thing. See, now format, there should be a specific format. The details should be structured in the PGP system. So the receiving end email system, whenever it receives the file and it should be able to get back. So this is the data structure. So the session key encrypted with the receiver's public key. This is the fields for that. Then actual signature of the document. And here message digest, which is encrypted with sender's private key. Okay, actual message, which is encrypted. Okay, and the entire thing will be passed through Radix 64. So this is the format of the that message and where the keys are used. Okay, PGP, even now GNU PGP is used, but generally it is at the personal level you can make use of that, because the public keys and all are shared only through the web of trust. That means only with the known people will try to share. There's nothing like digital certificate in this case. For that reason, at the enterprise level and all, we may not be able to prefer, but person to person, you can integrate the email to your email system like that. Okay. Second one, which quite often we use in our systems, another important protocol is Secure Shell, right? So it is again a client server application, just like Telnet, FTP. Whenever you want to log into the remote machine securely, we depend on this. Okay. So just like between the, it is an application level security solution between the SSH client and SSH server. A security handshake will take place, which will do strong authentication, integrity, and confidentiality. And again, verifying the server can be done either with the normal password or even with the public key, with the certificate kind of thing can be done. Okay. Once negotiated, you have a secure channel created between the, see, that's how you can remote machines you can access. Once you have a secure shell to the remote machine, through that you have multiple other protocols also can be used, FTP and other things internally, but outer layer will be your secure shell. Okay. So these again the similar direction. Okay. If you want, you can go to the, see, another very important thing which we use on a ray-to-ray basis is that HTTPS protocol, which is nothing but, as I told you, this is basically standardization at the transport layer. This is a standardization done at the transport layer. So where the different TCP applications can make use of this particular thing. Okay. Initially, it is developed by the Netscape, used for the client server applications. And as you are aware, whenever you are trying to enable SSL for your web service, you'll open the 443 port also in your firewalls. The reason is, so secure communication to the web server enabled with SSL will listen at 443 because it has to carry out the handshake for all the security related aspects and then carry out the communication with the browser. Okay. And whenever it is enabled with this thing, you'll have the URL with HTTPS. Okay. So that is a kind of, so where it resides deployment, it is going to reside at this particular layer. So secure socket layer is just below the application and above the transport layer. It is a generic APIs are created so that any kind of TCP based application can use it. Okay.